Hello Year 11s, I hope everything is well. As you may remember, 25th of February, we all had to do a Microsoft Forms remote assessment on the topics you guys learnt during the remote learning period. So I'm going to go through it and answer all 22 or 23 questions. And please make sure you use this video and the timestamps within the video to revise particular questions and learn how to answer particular questions. So question 1 is, so it says here, which region is represented by the diagram? So we have a few options. As you can see here, this region is the intersection of E and P. So E and P. Remember, this means E and P, and this means E or P. But because it's E and P, our option is going to be, we're going to select this second option. Question 2, the scatter graph shows the time students spent revising and their marks in a test. One student's score is an outlier. What is their score? So we can see their line of best fit. Most of the figures are not too far away. I'd say the one which is slightly more further out than the others is this point here. So the coordinates will be 5.3, 2, 4, 6, 46. So 5.3, 46. Those are the coordinates for this outlier. Question 3. 5 cards are numbered 1 to 5 and placed in a box. Halima chooses a card, keeps it. So I'll underline this. Keeps the card. So she can't select 2 ones, for example. So yeah, she keeps her first card and then selects a second card. So she only selects 2 cards in total. Where's the probability that her 2 cards total 5? So let's fill out this table. So if she selects number 1, then she can't select 1 again. And it's the same with if she selects 2, she can't select 2 again. So I'll just put little dashes in these boxes. And let's fill out the rest. So 1 plus 2, 3. We're going to go up by 1 each time. And notice we can kind of see a pattern develop. 5, 5, 6 here. 7, 7, 7, 7. Okay, so the question is, what is the probability that her 2 cards add up to 5? So we have 1, 2, 3, 4. 4 out of, so it's a 5 by 5 grid. It's 25 in total, but we're not going to count these ones. So we are not going to count these 5. So we're going to say 4 out of 20, which can be simplified to 1 over 5. Question 4. Okay, we've been given a Venn diagram as well. So everything is, so remember this E means everything. So integers from 1 to 12. Let me zoom in. Integers from 1 to 12. F contains factors of 12. So factors of 12 are 1, 4, 6, and 12. P prime numbers, write the set of numbers which represent F or P. F or P. So it can be F OP, and it says use braces and commas to write your numbers like this. So this is set notation. So they said FOP. So let's just shade in, or we can just circle it actually. Yeah, we'll just circle it. So F or P, so it's either in here or in here. Use braces and commas to write your numbers like this. So let's write it in order. So 1, 2, 3, 4, 5, 6, 7. So all the numbers apart from 8 and 9. Yeah, 7, 8, 9, 10, 11, 12. And we need to remember the braces at the end. So here it is. I think that's right. Yes. So as I said, the only ones we haven't included are 8, 9, and 10. Question 5. Zebra's draw contains 6 red socks and 3 white socks. She selects a sock at random, puts it on, and then selects a second sock at random. What is the missing fraction on her tree diagram? So it helps to have a tree diagram for this one. And so yeah, 6/9. If she has taken a red sock and she hasn't replaced it, then that means the probability here will be 5/8, because she started off with 6 red socks and now she only has 5 red socks left. And that's it actually. Yeah, that's it for this question. Yeah, and it says give your answer as a fraction. Question 6. In a class of 30 students, 15 play football. So let's say 15 play football. 7 boys. Okay, now it's getting complicated. So 7 boys don't play football. 6 girls do play football. If a girl is selected at random, what is the probability that they play football? This looks like a conditional probability question because they're talking about if a girl is selected at random. So I'm going to write here, given that a girl is selected at random, I think the easiest thing to do here is fill out the Venn diagram. So 30 students in total, so I'll write here 30. 15 students play football. So we know that 15 will play football, but I don't want to fill it in too early, because if I say 15 here, then that's implying that no girls play football. Let's rub it out for now. So we know 15 play football, 7 boys don't play football, and 6 girls do play football. So 6 people are girls and they play football, so 6 girls play football. So I'll cross this out actually. 7 boys don't play football. Okay, so if you're not a footballer and you're not a girl, then we'll write the value outside. So here, they're a part of a group, but they're not in either of those circles. So I'll cross this out as well. And that helps us know which part of the which of the information in the question we have used. So now we just have this 15 students play football. 15 students play football. Okay, 15 take away 6 is 9. So let's rub this out. And so we have 9, 6, and 7. So we know that they need to add up to 30. So 30 take away 15 take away 7 equals 8. So we need to have 8 girls who do not play football. Where's the probability? So now let's go back to the question. Given that a girl is selected at random, what is the probability that they play football? So we're narrowing the group down from 30 individuals to the total number of girls, however many that may be. So I'm going to circle this one because it says given that a girl is selected. So a girl is selected. Where's the probability that they play football? So in other words, where's the probability of girl and footballer over probability of they're a girl? So 6 girls are footballers and there are 14 girls in total. 6 plus 8 is 14. And again, we can simplify this fraction. 3 over 7 is the final simplified answer. Question 7. Lucy works in a school office. She records the length of time spent on each phone call. Estimate the mean length. So I'll underline mean. It looks like we're going to work out the mean from a table or using a table. Estimate the mean length of a phone call to the nearest minute. So let's complete this table. 1.5, 4.5, 7.5. I'll use a calculator to complete this table. So just to explain what I did, I worked out the fx value by multiplying each f, so each frequency, by its corresponding midpoint. So 41 multiplied by 1.5 is 61.5, and so on and so forth. So the totals are 60 and 183. And lastly, we need to do 183 divided by 60, which is 3 and 3 over 60, 3, 1 over 20. So as actually it says estimate the mean length to the nearest minute. So to the nearest minute, the answer would just be 3 minutes. Question 8. Freya is drawing a Venn diagram to show the elements of sets A and B. Use her diagram to decide which statement must be true. So the first thing I spotted with this diagram is that there is no intersection. So there is no A and B. So in other words, A and B equals 0. And one way of writing this is using this notation. Remember that this symbol means empty set. So there are no numbers which are in A and B. There are numbers in A, there are numbers in B, but none are in A and B. So this one would be correct. Question 9. There are... That looks like a typo. Yeah, there are 8 women. Sorry, there are 8 men and 5 women in a room. 2 adults. So let's circle that. 2 adults are selected at random without replacements. That's really important. Noah has made a mistake calculating the probability of selecting a man and a woman. What should the correct answer be? Okay, so I'm going to first fill out the probabilities which are not on the tree diagram. So, okay, that's not great. 5/13 without replacements. So this becomes a 7. And here we will have 4/12 and 8/12. So let's look at their calculation. They're saying the probability that we have a man and a woman is this, which is partially correct because what they've done here is, okay, that's not great. So what they've done here is, okay, this isn't working. They've multiplied this with this, which is fine, but you also need to add it with, let me just check the question again. Probability of selecting a man and a woman. Okay, so what they've done is they've worked out the probability that you select a man and then select a woman. But remember, the order doesn't matter unless they state that it does. The order doesn't matter. So we need to work out the probability of us selecting a female followed by a male. So that would be this multiplied by this. And so it's actually pretty much the same as the other one. 40/156, 10/39, and so the total, we just have to add them together. So the total will be, alright here, total probability of selecting a man and a woman in no particular order is 20/39. 10/39 plus 10/39 equals 20/39. Okay, a year group of 120 students went on an adventure holiday and completed various activities. 15 only did bowling, 65 did bowling altogether, 60 did canoeing, and okay, that's a lot of information. I'm going to start filling out the Venn diagram. So we know we have 120 in total. 15 did bowling and 65 did bowling altogether. Okay, so I know the 3 values or 4 values will combine to give a bowling total of 65. So the blue circle will total up to 65. 60 did canoeing. So let's make a note of this as well. 35 did canoeing and archery. Okay, so this is very clear. Actually, we'll leave that as well. 35 did canoeing, 28 did bowling and canoeing, 12 did all 3, and 7 did none of them. Okay, we'll start off there. 7 did none of them, and 12 did all 3. 12 did all 3. So now I'm going to cross this out. And we're going to work our way up. So we'll focus on this one. 28 students did bowling and canoeing. So 28 did bowling and canoeing. 12 of them also did archery. So 28 equals 12. 28 equals 12 equals 16. So we're going to write a 16 here. So I'll cross this out. 35 did canoeing and archery. So again, what that means is 35 are within this range. And so we have to write 23 here. 23. Let me just get rid of those lines actually. 23. So let's cross this out as well. 60 did canoeing. Okay, so now these four values, so these three values and this final value will have to add up to give us 60. So we have 28, 48, 51, so 9. I hope this is correct. Yeah, 9. Cross this out. 15 only did bowling and 65 did bowling altogether. So 15 only did bowling. 15 only did bowling. No other activities, just bowling. 65 is the total. So 15 plus 12 is 27. Plus 16 is 343. So 22 goes in here. And how many students only did archery? Okay, finally we can get the final answer. So let's do some calculation here. We have 120 in total. So 120 take away 65. Take away 60. Okay, that doesn't make sense. 65 did bowling altogether. Okay, no, I've been doing that wrong. Let's just cross this out because it's starting to confuse me. 120 take away 65 from bowling. We have 55 left. So what that means is these guys and these 7 will add up to give us 55. So let's write 55 take away 7 equals 40. 48 take away 23. So we've dealt with this one. All right, with blue, we've dealt with this one. 25. So now we have eliminated this one. And now we're going to do 25 take away 9 equals 16. So 16 only did archery. I'll underline this one as well. And using a different color, I'll write 16 in here. So 16 students only did archery. Question 11 is a follow-up to question 10. It says here, using your answer to the above question or otherwise, find the probability of students who did canoeing given that they did bowling. Given that they did bowling. So what I'm going to do here is circle the bowling circle, the blue circle. And we need to work out the probability that the student did canoeing. So how many students did canoeing? Well, we can see that these guys, 12 plus 16, these 28 people did canoeing. So, I'll write here, probability that they did canoeing, given that they did bowling, or given that they did bowling as well, is the probability of them doing canoeing and bowling divided by the probability of them doing bowling. So the answer will be 28, because we've added, don't want to mess it up, but we've added the 12 and 16 together, divided by probability of bowling. So how many people did bowling in total? I think it was 65. Yes, I just looked at the question. 65 people did bowling in total. So 28 over 65. Question 12. The ratio of boys to girls in a class is 2:1. Remember, the order is really important. If the probability of randomly selecting 2 girls without replacement is 5/51, how many students are in the class? Okay, that's an interesting question. Okay, so the ratio between boys to girls is 2 to 1. So the probability of selecting a boy is 2/3, and the probability of selecting a girl is 1/3. But let's think about how many students are in the class. And so let's say 2x plus, so let's just say 2x, where 2x plus x equals 3x, and that would be the total number of students in the class. And so we could write the probabilities as 2 multiplied by x over 3 multiplied by x. So our total number of boys is 2x, and so I will write 2x. Total number of girls is x. Total number of students in total is 3x. Going to look messy. So this. Now I'm going to zoom in on the tree diagram. Let me just make it a bit smaller. So x over 3x. And 2x over 3x. 2x over 3x. We're just focused on selecting 2 girls. So if you select 1 girl already, remember you have to take away 1 from the numerator and take away 1 from the denominator. So x take away 1 over 3x take away 1. So we know that this multiplied by this gives you 5/51. So let's solve for x now. Where should we do that? Let's say here. X over 3x multiplied by equals 5/51. Let's see, some cancel out with each other, so this and this goes. So I will write x equals 1, 3 times 3 is 9. I'll keep it. Sorry about this. So let's just keep it like I don't want it to get too complicated. Cross multiply. So 51 x take away 1 equals 5 times 3, which is 15. 3x take away 1. 45, x take away 15. Subtract 45x from both sides, we get 6x equals, then add 51 to both sides. 36. So x equals 6. And if x equals 6, how many students are in the class? How many students are in the class in total? 3x is how many students are in the class in total. So 3 multiplied by 6 is 18. There are 18 students in the class. 9 girls and 18, so that doesn't make sense. 12. Oh, sorry. 12 plus 6. 12 boys, 6 girls, 18 students in total. Question 13 says the first graph shows the English and art exam scores for a class. The second graph shows the maths and English scores for the same class. Where's the correlation between maths and art? So let's zoom in to this graph, or these two graphs. So we have two scatter diagrams. Remember, scatter diagrams are graphs which have two variables. Here we have two variables. We have a negative correlation here. Let me just write negative. That's negative. Positive correlation here. So we want to know the correlation between art and maths. So maths has a positive correlation with English. And art has a negative correlation with English. So I'm going to cross this out and write maths. Because English and maths have a positive correlation with one another, we could just replace the English with maths, and English with art would also give a negative correlation. So we would have to tick off the negative option. Question 14. There are 4 apples and 3 oranges in a fruit bowl. 3 pieces of fruit are selected at random without replacement. What is the probability that at least 2 apples are selected? So let's use this tree diagram. So 4 apples, 3 oranges in a fruit bowl. So let's write 4 over 7. So 4 over 7, 3 over 7. It says without replacement, so we're not going to replace them. Okay, let's continue. 3 over 6, 2 over 5, 3 over 6, 3 over 5, 2 over 5. You need to just think about it very carefully. If you're taking an orange away, you're going to get 1 less orange, and same for the apples. So for here, we're taking an orange away, so we have 2 over 7 here, and 5 over 7 here. Taking an orange away, we have 1 over 7. Oh no, 1 over 6. 1 over 6. 5 over 6. If we take an apple away, then we're going to get 4 over 6 and 2 over 6. So what is the probability that at least 2 apples are selected? At least 2 apples. So we could, so the possibilities are selecting 3 apples, selecting 2 apples and an orange, selecting an apple followed by an orange followed by another apple. This one doesn't count. This one does count because we have 2 apples. And I'll just cross out the ones which do not count. So we need to work out a few probabilities and then add them together. Of course, for this type of question, you would be allowed to use a calculator. Okay, so to ensure this doesn't get too messy, I'll call this 1, 2, 3, and 4. So let's say 1 is 5, which is 24 over 2, 10. 2 is... Okay, what I've noticed here, for 2, we have apple, apple, orange. For 3, we have 2 apples and an orange. For 4, we have 2 apples and an orange. So they'll actually probably have the same probabilities. Let's just work it out. For 2, we have 4 over 7, 3 over 5. And this gives us an answer of 36 over 210. For 3, we have... By the way, these are multiplication signs. There should be multiplication signs between these 3 fractions. Question 3, or the third probability, is 4 over 7 times 3 over 5. So as you can see, the values are exactly the same as the second one. So 36 over 210. Part 4. 7. And I noticed a mistake, which changes everything. Okay, so this should be a 6. This should be a 6. 5, 5. 1 over 5. 4 over 5. Sorry about that. And I'm hoping you guys didn't make the same mistake, or at least spotted it earlier. So we have 3 over 7 multiplied by 5 over 6. Is that right? Yeah, 5 over 6. This one should be 4 over 6. This one should be 3 over 5. Shocking. So, as you can see here, you have 3 multiplied by 4 multiplied 3 multiplied by 4 multiplied by 3. It's the same as the above one, and you have 7 multiplied by 6 multiplied by 5, and it's the same here as well. So without even using a calculator, I know that this will be 36 over 210. Since these are all the possibilities which we can have, we need to then add them together. So the probability of 1 or 2 or 3 or 4 equals the sum of these 4. So this, I don't know how to denote it, but let's just say the sum of these 4 fractions. So if we add them up, get 132 over 210. Divide top and bottom by 2, you get 66 over 105. Now we can divide by 3. Divide top and bottom by 3, so we get 22 over 35. And we cannot simplify any further. So as you saw with this question, you need to be really careful, especially here. As you saw, I made a few mistakes, but hopefully if you don't rush, then you won't make those silly mistakes. So question 15 says the mean estimate for the age of a child in the group recorded in the table is 5.8. If there are y children between ages 4 and 8, what is the value of y? So we need to work out y. It's kind of the opposite of the question earlier where we had to work out the mean. So we know the mean, the estimate of the mean is 5.8. We need to work backwards to see what y is. So this is going to be 11 plus y. And here we have 62 plus 6y. The estimated mean is 5.8, so 5.8 equals 62 plus 60y. Sorry, 62 plus 6y. I'm not sure why I didn't write that here. Divided by 11 plus y. So multiply both sides by 11 plus y. You get 50. I'm not sure off the top of my head. Alright, 58. 5.8 times 11 plus 5.8y equals 62 plus 6y. So 63.8 plus 5.8y is equal to 62 plus 6y. Now we just solve for y, so equals 6y, great. 1.8 equals 0.2y. Divide both sides by 0.2 and we get y equals 9. Y equals 9. Let's look at the question again. Where's the value of y? Yeah, so we just worked it out. Y equals 9. So we can write 9 here. Find the highest value of a box plot given that the range is twice the interquartile range. So find the highest value. Okay, let's work out the interquartile range. So the interquartile range is 52. Take away, what is that? 28. So the IQR is 2 to 4. 4 plus 20, 24. So the range is double. The IQR range is 48. And so it's going to be 15. So it's going to be the highest value take away 15. So let's write x take away 15 equals 48. And so x equals 63. Question 17. Graph A shows the graph of y equals f of x. What is the equation of graph B? So we have some options here. Depending on the type of transformation, we need to select one of them. So graph A is f of x. We need to work out what graph B is. So here we have the turning point at x equals 0. X equals 0. That's when our turning point is. We can see that the graph is not moving up or down. It's not. It looks roughly level. Look, I'll even draw a dotted line between them to show you. The graph looks roughly level, so it's not moving up or down. So the y value stays the same. All the y values are staying the same. Y is unaffected. Y is unaffected. It seems to me that the x values are being affected and the x values are changing. So x is being the graph is moving in this direction. So remember, when the graph moves to the more positive direction, it is actually a negative. So the transformation is f of x take away, I'll just write a for now, where a is a number, a positive number. So it's being shifted by 7 places, it seems, because of our options. It's clear that it's being shifted 7 places to the right. So I will say that this transformation is f of x take away 7, because, remember, shifting to the right is this type of transformation, so f of x take away 7. And if you shift to the left, it would be f of x plus 7. That's shifting to the left. So we need to tick, which one was it? F of x take away 7. So we need to tick this one. Point A is on the graph y equals f of x. The transformation maps f of x onto negative f of x. Sorry, the transformation that maps f of x onto negative f of x maps point A onto point A dash. What are the coordinates of A dash? Alright, so this is f of x. This is f of x. So negative f of x is going to be a reflection. Remember, if it was like this, then that would be a reflection in the y-axis. So reflection in the y-axis. But because it is like this, it's a reflection in the x-axis. So in other words, the x values are not changing, but the y values are. I'll say that again. The x values are not changing, the y values are. So this reflection would look something like this. So I'm just seeing where this is 1, 2, 3, 4, 5, 6. So I'm going to go 6 up. 1, 2, 3, 4, 5, 6. Let's do it here. And just do a rough curve like this. Something like this should get you the mark. So it says, so this transformation maps point A to point A dash. So here we have A, the reflection would be here. So this would be A dash. A dash. So as you can see, the x value is not changing, but the y value is, it's being reflected, and so it would go from -2 to +2. So I'll write here, I'll say that again, x value is not changing, so we'll write this. The y value, it will become positive, so it's -2 right now, and the new value is +2. That would be our answer, -8, 2. So question 19, the cumulative frequency graph gives information about the times in minutes 140 girls revised for an exam. Find an estimate for the median. Give your answer as an integer. So firstly, we can see that with this cumulative frequency plot, they add up to, well, the total number of girls, total frequency is 140, and it says that in the question as well. 140. We can see that the cumulative frequency, it starts here, and that may confuse some students, but that just means that every girl has revised at least 10 minutes. So in other words, no girls revised 0 minutes. So I'll just complete this. frequency graph, because they should start as 0, cumulative frequency graphs. So we have 140, and so the easiest way of working out the median is looking at the 70, so halfway between 140 and 0 is 70. So we're going to draw dotted line and draw a line down. So that corresponds to 42, 43, 43 minutes. But again, in an exam, in an actual exam, they would be flexible with regards to the answer you put. So getting, if you answer 41, anywhere between 41 and 45, you'd probably get the marks on this question. Just as a bonus, let's work out the upper quartile, and the lower quartile. So the upper quartile will be, since the median was half of 140, upper quartile will be 3/4 multiplied by 140. The lower quartile will be 1/4 multiplied by 140. So another way of doing it is just by halving 70 again. If we half 70, we get 35. So this is 30, and this would be 35. And the other one would be 105. So here we have 110. To do the upper and lower quartiles, and I guess that's why they didn't ask it as well. The scales aren't really appropriate for the upper and lower quartiles, but we'll try to work out some estimates anyways. So you just draw the lines to the cumulative frequency graph. Draw a line down. So the upper quartile will be roughly, because as you can see my annotations aren't the best, 56 minutes for our upper quartile, and our lower quartile is roughly 20 minutes. Question 20. There are only green pens and blue pens in a box. There are 3 more blue pens than green pens in the box. So just by reading that, I actually know that we'll have to use some algebra. They want us to compare them. So there are 3 more blue pens than green pens. So I'll write X above green pens and 3 more blue pens. So X plus 3 here. There are more. Sorry about that. There are more than 12 pens in the box. Okay, we can't really do much about that now. Simon is going to take a random 2 pens from the box. So this already makes me think about a tree diagram. So we'll make 2 selections. The probability that Simon will take 2 pens of the same colour is 27 over 55. Work out the number of green pens in the box. So it looks like quite a long question. If we have X plus 3 blue pens, if we have X plus 3 blue pens and X green pens, then let's add them together. Let me do that in a different colour. Add them together to work out a total of 3x plus 3. No, 2x plus 3. 2x plus 3. So this is our total. So now let's do our tree diagram. Try to make it a bit bigger. So we have x plus 3 over 2x plus 3. X over 2x plus 3. Okay, so do they mention replacing the pens? There are going to take 2 pens from the box. They don't mention anything, so we'll assume that they do not replace the pens. Usually they'll mention it if they're going to put the pens back into the box. So because they're taking a pen and not replacing it, in other words not putting it back into the box, we need to take that into account and change our probabilities after selecting one pen. So x plus 2 over 2x plus 3 take away 1 is 2x plus 2. For this one we'd have x over 2x plus 2 so here we have x take away 1, 2x plus 2, and we have x plus 3 over 2x plus 2. And you could actually check your probabilities by adding these two, the answer should be 1, and adding these two together, the answer should be 1 as well. Okay, so now we need to think about what colours these are. So blue, blue, this one's blue, green, green, green. So it says in the question, the probability that Simon will take 2 pens of the same colour is 27 over 55. So in other words, this multiplied by this plus this multiplied by this is 27 over 55 plus 2x plus 2 plus, let's just do this. They have the same denominator, so let's write it like this. So on the top we have x plus 3, x plus 2, plus x take away 1, equals 27 over 55. Let's see if anything cancels. Not yet. Okay, we'll probably have to just keep going and eventually solve the quadratic expression, or equation I should say. X squared plus 5 plus 6 plus x squared take away x, 4x squared plus 6x plus 4x, so 10x plus 6 equals 27 over 55. To save space, I'm just going to collect the like terms here. So x squared plus x squared is 2x squared. So 2x squared, and this gives you 4x. So 2x squared plus 4x. Plus 4x plus 6. We can simplify it because I can see here we have even numbers here as well. So let's write write this out. Alright, here 2x squared plus 2x plus 3, 2x squared, 2x squared plus 5x plus 3. So the 2's will cancel with one another. So we have x squared plus 2x plus 3 divided by 2x squared plus 5x plus 3, and that is equal to 27 over 55. So let me just rub out let's just rub these out. Okay, that's not... Okay, let's just say here equals 27 over 55. I'm trying to spot a shortcut, but I don't think we have one. Let's just cross multiply, and using a calculator this shouldn't be too much effort. Cross multiply and you get 55 x squared. Let's just multiply them. Okay, wait, let's just write like this first. Plus 2x plus 3 equals 27 2x squared plus 5x plus 3. Solving for, if we subtract 54x squared from both sides, we will get x squared. If we were to subtract 100 and... let's see, 54x. Okay, we need to subtract 135x from both sides, and we get negative 25x. Subtract 81 from both sides, it's 84. That's right, equals 0. Please take your time if you are doing this type of question in an exam or just practicing at home, and you'd probably be allowed to use a calculator. Here we have two numbers which multiply. X take away 21 and x take away 4 would work. Yeah, so let's just go back to the question. Work out the number of green pens. Okay, the number of green pens corresponds to x. So in other words, we need to find x. That's what we need to do. There are more than 12 pens in the box. Okay, that would help. There are more than 12 pens in the box. So x equals 21 or x equals 4. However, because of the condition here, there are more than 12 pens, gonna cross this out. We know we have 21 green pens. 21 green pens, and so that means we have 24 blue pens. The histogram shows information about the ages of the members of the football supporters club. There are 20 members aged between 25 and 30. One member of a club is chosen at random. What is the probability that this member is more than 30 years old? So the 20 members thing is probably going to be important. We know that the frequency of the third bar is 20. And so this is 25. So the base of this rectangle is 5, and the height is a very large number. Okay, but we know that 20 divided by 5 is 4, so the frequency density has to be 4. So it's 3. Can't actually zoom out. So 2 and 1. That makes sense. Distance, but oh no, the 1 doesn't make sense. Here we have a 1. So this is a 1. Okay, yeah, now we have the frequency densities. One member of a club is chosen at random. What is the probability that this member is more than 30 years old? So we need to use the frequency densities and the ages, or the class widths, plural, to work out the frequency of these two, and then divide it by the total frequency. So let's cross this out for now. Here our class width is 20, and here we have a class width of 30. Let's just write 30. Alright, so the frequency density for the fourth bar is here. Okay, let's see, 2.6. So 2.6 multiplied by 20 is, let's see, 2.6 multiplied by 20, 52. So alright, 52. The next one, we can see they're going up by 0.1. So 0.1, 0.2, 0.3, 0.3 multiplied by 30 is 9. So what is the probability of a person being older than 30 years old? So in total there are 61 people who are older than 30. How many are there in total? We do not know. Okay, so that doesn't help. We need to work out the frequency of every single group. So here we have 2, 15, 30. So 30 people are in that range. And here we have 10 multiplied by, what is this? 3, 4, 5, 6, 7. So 0.7 multiplied by 10 is 7. So our probability is going to be 61 over the total, which is 61, let's do it here, 61 plus 57, so 118, Yeah, 118. 118. This is our probability. Given that PA, so probability of A is 0.4, probability of B is 0.3, probability of A and B is 0.2, what is the probability of B given that A does not occur? Give your answer as decimal. Do not include notation. Hint, drawing a Venn diagram. Let's draw a Venn diagram. Again, not the best Venn diagram in the world, but should suffice. So A, B. I think there's one already. Oh no, there isn't. Okay. Probability of A 0.4. Actually, let's do this one first. Remember, always start with the overlap. 0.2. The probability of A is 0.4. So we're going to have to write 0.2 in here as well, because these two need to add up to 0.4. And probability of B is 0.3. So here we need to write 0.1. So that these two add up to 0.3. And lastly, we need to work out the probability that it's not A or B. So these add up to 0.5. So 1 take away 0.5 is 0.5. Okay. Where's the probability that it is not A? So by it not being A, we mean, I'm going to shade it a particular color. So in other words, we need to do 1 take away the probability that it is A. So I will write, I want to shade it in. Okay, let's just shade it in like this. So this shaded region is everything which is not A. And the right probability that it's not A is 1 take away probability of A. So 1 take away 0.4, 0.6. Okay, so we've done part of this question. What is probability of B? So probability of B, given that not A, is the probability of B and not A divided by the probability of not being A. So, what is the probability that it's B and it's not A? So I'll shade that in as well using a different color. So it has to be within the yellow region and it has to be B. So let's shade it like this. So it's going to be this bit, which is B. Okay, something like this. So now the probability will be 0.1 because of that green region over probability of it not being A is 0.6, and I'll use this color. I hope that is visible. So this is just the same as 1/6. And as a decimal, well, I can tell that it's going to be a recurring decimal. 0.16 recurring.